Hello everyone, today let's solve the problem number 49 and group anagrams, right? So what the question states here, we are given an array of strings strs. You can clearly see here, we are given an array of strings strs. We have to group the anagrams together. So we have to group the anagrams together, and they have mentioned that we can return the answer in any order. So order doesn't matter here, we can return the answer in any order. So what is anagrams basically? When I hover the give me a second here, when I hover over the anagrams word here, um, it is showing that an anagram is a word or a phrase. So an anagram is a word or a phrase that is formed by rearranging the letters of a different word or phrase using all the original letters exactly once. They have mentioned clearly. An anagram is a word or a phrase that is formed by rearranging the letters of a different word or a phrase using all the original letters exactly once. So what does it mean here? Let's consider a simple example here. So suppose in the we have the word ABC here, right? So we have another word CBA here, right? So when we sort this one, so based on the ASCII value, we will get here ABC, and here also for this word also we get ABC based on the ASCII value. If we sort this one, this becomes ABC, this becomes ABC as well. So this has to be equivalent, right? So this word is equivalent to this word, then only we will be saying that both these words are said to be anagrams, right? So here in this case, the character count, so here we have CBA and we have ABC. So the character count has to be same of the original word. So suppose this is the original word that we have considered and this is the another word, right? So here in this case, the character count, the characters that are present in the original word has to be same here for this word as well, and the character count has to be same. So here in this case, you can clearly see when we sort this word, this word, when we sorted this one based on the ASCII value, we got ABC. Here we have already ABC. Even if we sort the original this one word, we have ABC itself, right? This is already sorted. So we got ABC equals ABC. The count, so here you can clearly see A is present once, B is present once, and C is also present once. In this case also A is present once, B is present once, and C is present once. So then only if these things matches, basically then only we will set these two words are said to be anagrams, right? So this is what the anagram is, right? So let's come to the first example here. So let's come to the first example here. What we are asked to do here, we have to group the anagrams together. We have different anagrams. We have to group the anagrams together and we can return the answer in any order they have given. So we are given an array of strings, right? So we are having many anagrams, different group of anagrams. We have to group the anagrams together, right? That's what they have given here. You can clearly see here in this case, we have eat, tea, tan, ate, NAT nat, and BAT bat, right? So first we have the bat. So by only bat here in this case, we doesn't have the another word that matches. So this we have we are showing this one in the single array, right? So next we have NAT and TAN. So NAT and TAN, if we sort this one and based on the ASCII value, what we will get? A and T. Yeah, for the NAT also we get A and T, and for TAN also we get A and T, right? So that's what we that is why we this one has been grouped into the another array, right? So I hope this is clear. Next, when we come to this one here, the third array, here we have 8, eat, and T. So when we this one sort 8, this will be A, E, T. When we sort eat, then also it is AET based on the ASCII value. And when we sort T, then also it is AET. So these three things are grouped into the another array, right? So that's what we are grouping different anagrams. Different group of anagrams into the single array here in the output. right? I hope this is clear, right? I hope this is clear. They have clearly mentioned we have to group the anagrams together, right? Same goes with the example 2 here. We have been given empty array. So here only one set we will get into the new array, nothing but empty array itself, right? In this case we have single character within the this one array. So we have to group the same thing into the new array A with a single character, right? This is one anagram. So I hope the examples are completely clear. I hope the question is clear as well. I hope the question is clear. What we need to do is completely clear as well, right? First, what we will do, let's discuss the approach. I'll just consider the first example. As we have discussed this one, it will be easier to understand. So let's discuss the approach first, followed by edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, as usual, let's discuss the approach. So here, first thing we need to keep in mind here is we will be going with the hash map as well as the sorting, or hash map plus sorting approach, right? So we will be making use of hash map plus sorting, right? I have considered the same example, the first example that they have given in the question, so that it will be easier to understand, right? We already know how we got the output, right? First, we have sorted this one, we have grouped this one different anagrams, and we have pushed that one into the new array. So we have already discussed this one, right? So let's come to the step-by-step execution part here. So in this case, first step, we will create the hash map, or I have considered the variable name map here. You can give anything. Here, first step, we will create hash map to store the anagrams, that is grouped by sorting the string as key. I am again telling this one is very important. So we are creating the hash map to store the anagrams, right? So we have to store the anagrams somewhere. So we are creating the hash map to store the anagrams, that is grouped by sorting string as the key. That is sorting string as the key. Why we are doing this one? At the end, we can just this one return the value for the particular key that is grouped into the single array, right? So that is how this helps basically. That is the reason. So we are grouping by sorting string as the key. So let's come to the process, right? So let's discuss the process, each word in the strs here in this case. So in this case, we have the word eat. So when this is sorted based on the ASCII value, we get A, E, T, right? First word is A, then the second word is E, then it becomes T. So we are storing this one in the map. So we have already discussed that we will be we will store the anagrams group by sorting string as the key, right? So here in this case, we will store in the map. When we store this one in the map, we will get in this way. A, E, T, this is key, then the value here is EAT, the word, we are pushing the word as the value here in this case, right? So this one will be in this way, right? So now we got this one. So let's come to the second word T here. So again, when sorted, we got AET, right? So when we sorted, we got AET. Based on the key remains same here. The key remains same here. We are pushing into the same key as we got the this one. When sorted, we got the same word, right? So we are pushing this word to the same value here. Here in this case, this becomes EAT, and this becomes TEA, right? This becomes TEA in this case. I hope this is clear. The third word here is tan. So when sorted, this becomes ant. So this becomes ant, and we got the new key here. So till now the key was AET here. Twice we got the same thing. So till now the key was AET. We got the new key here. So this remains same here. In this case, AET was the previous key, and the word we got here as EAT here in this case. Just give me a second here. So what happened to this one? So this became here. Just give me a second. AET here in this case, TEA, and we got the new key this time. We got the new key this time, nothing but ant here. this will be, we can write in this way, ant new key, and the word we are pushing here as 10. To this key we are pushing 10, right? So I can write in this way. So this will be 10, right? We got 10 here. This is fine. So this is for the third one, 10. So next let's come to the word 80. So here for the 8 word, when we sort this one, we get ET, right? So we get ET, nothing but here in this case. So in this case, when we sort 8, we get the word 80. So we already have the key 80 here. You can clearly see 80, 80. We are pushing this word to the same key, right? So when we push this one, what happens here is, just give me a second here. This one will be 80, and the words that we pushed previously was, so here we have AET, TEA, right? So just give me a second here. AET, TEA, and the new word we got here is AT. So this one, let's push to the same key here in this case. So this one remains same. So the previous one, this one for the key ant. So this one will remain same. I'll just give here ant with the word 10, value 10. Sorry. This is fine. The fifth word is nat here. In this case, when we sort this one, we get the ant, and we already have the same thing. We already have the sorted ant here, key, right? So I'll just write the same thing here. 8 remains same here. In this case, this will be AET, TEA, ATE in this case. So for the ant here, we have the word now 10, as well as we will be pushing NAT as well, right? So when we sort, we got the same word, so we are pushing it to the same array here in this case. This is fine. So let's come to the final word here, bat. We will come to the final word here, bat. So we got the new key here, right? So ABT, when we sort this one, we get ABT. So ABT is not present, right? Previously we haven't, when sorted, we haven't found the word ABT. We have found AET and ANT, right? So this one, we got the new key here. So we will be pushing this one to the new array in this case. So here in this case, I can write in this way. AET, we already have this one. EAT, TEA, and ATE for this particular key, right? So next, for the key A and T, we have got the words basically TAN and NAT, right? We have got the words TAN and NAT. For the final one, so for the ABT, this one, what we got? So this word, we are pushing this word, VAT here. So finally, we got this solution, right? So what we will do in the final output here is, we will return the value. We will ignore the keys and we will return the values. When we ignore the keys and we will return the values, we will get the final output as this one, BAT. NAT, you can return the output in any order, so it doesn't matter. BAT, NAT, TAN, ATE, EAT, and TEA. So this is same, or this is equivalent to the output that they have given for the example 1. BAT, NAT, TAN, ATE, EAT, and TEA, right? So this is equivalent to the output they have provided for the example 1. So the approach works absolutely correct in this case, right? We have went with hash mapping plus sorting. So the approach works absolutely correct in this case, right? As we are familiar with the approach, now let's move on with the edge cases one by one. So the first edge case here we need to consider here as empty string input. So we have considered empty string here. The output is same here, this one, right? So the output will be same thing. So we are pushing the empty string to the new array, right? So only one thing. So let's come to the second edge case here, single character string. So we have the single character A, right? So we the only one group exists here in this case. Just give me a second. Yeah. So only one string exists, so it forms its own group. So previously we had empty string. So this one, basically when we sort the empty string, it results in empty string itself. So it remains in its own group, right? Here in this case, now we know we have only one string, so it forms its own group here. So let's come to the third edge case here. When I say third edge case, we are dealing with all words are unique. When I say all words are unique, we have unique words here: A, B, C, D, E, F, and G, H, I. So each word has a unique sorted representation. So here each word will be grouped into the new array: A, B, C, D, E, F, and G, H, I. Right? So each word has a unique sorted representation here. So the output will be A, B, C, D, E, F, and G, H, I. All the words that are pushed into the new array. Right? The final edge case here is all words are anagrams. All the words are anagrams here. So we have ABC, BCA, and CA. Right? So here sorting all the strings gives ABC itself. So when you sort this one, ABC, BCA, ABC is already sorted based on the ASCII value. So BCA and CAB, when you sort, you will get ABC itself, right? Based on the ASCII value. So sorting all the strings gives ABC itself. So they are grouped together, right? So they are grouped together. So the output will be within the same array: ABC, BCA, and CA, right? So I hope this is clear. These are the four edge cases that we need to consider here, right? These are the four edge cases that we need to consider here. The first one here is empty string input. The second one here is single character string. The third one here is all words are unique, and the fourth one here is all words are anagrams, right? So I hope all the edge cases are clear. Now we are familiar with the approach and we are familiar with the edge cases as well. As we are familiar with approach and edge cases, it will be easier to write the code. Right, now let's start writing the code. So earlier what we did, we discussed in the approach that we will be creating a hash map to store the group anagrams, right? So let's write that. I'll just go with a map here. Type string. I'll just give you a list of string. This is fine. So here in this case, I'll just go with a variable name map. We'll be making use of the hash map, right? So I'll just go with a hash map in this case. This is fine. The next step here is we have to iterate over the each word in strs. So I'll just go with a simple for loop here, so which is of the type string here, string s. So I can just write in this way, right? Strs of strs here in this case. So next step within the for loop, let's convert the string to the character or char array, and let's sort it to form the key. We have seen this one step by step in the approach already, right? So let's convert the string to char array and let's sort it to form the key. So I'll just write on this way: char array equals s dot to char array. This is fine. So I'll just we have to sort this one, right? We have to sort it to form the key. So how can I write this one? Arrays dot sort of, let's pass the array here. This is fine. So it has to form the key, right? I'll just make use of here variable name key. Let me give here new string of, let's pass the array here. So what we did till now, as I've already explained, so this is simple. We are just converting the string to char array and we are sorting that one to form the key, right? I hope this is clear till here. After this step, so just give me a second here. Yeah, after this step, we have to add the original string to the list of its corresponding key. So after sorting, we have added the original string or the original this one word to the list of its corresponding key, right? To the list. We may we push to the newer array, right? If you remember, here we are making use of the list, right? So we are adding the original string to the list of its corresponding key after sorting. So this one I can articulate this one in the form of code in this way. I'll just give here map.compute if absent here, this one will be key comma k new array list of this one. What should I do? I'll just make use of the property add here, add of s, right? This is fine. Property add, we are making use of the property add of the hash map. This is fine. So then what I'll do, the final step here is we have to return the group anagrams in a list, as a list of lists, right? As a particular list of lists. Again, I'm telling we have to return the group anagrams as a list of lists. So I'll just give here return new array list, this one. So I'll just give here map dot values in this case, right? So this is it for the code. Simple, right? So let me hit the run button. I hope this works. Let's see. Oh, we have the compiler here. The line number 5. So yeah, this is saying bad initializer for loop, right? So I have given colon by mistake. So I'll just remove this one. Let me hit the run button again. Hope this works. Let's see. So yeah, now you can clearly see the sample test cases are getting passed. Let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? Let's quickly discuss the complexities for the code that we have written. So here we know the approach that we went with here is hash map plus sorting, right? So the approach that we went with here is hash map plus sorting. So overall, what is the overall time complexity here? Overall time complexity would be here in this case because of n into k log k. So again I'm telling the overall time complexity here is because of n into k log k. So why it is because of n into k log k? Because of n, because we are iterating over n strings. So we are iterating over n strings, right? So this one for loop because of n, because we are iterating over n strings, and we are because of k log k, because we are sorting each string. We are sorting each string. Where we are sorting, just give me a second here. Here we are sorting each string. K is max length of a string, so it will be because of k log k, right? I mean k log k for the sorting. So in this case, overall time complexity would be because of n into k log k, right? So what will be the overall space complexity here in this case? The overall space complexity would be because of n into k. So why it is because of n into k? Because we are storing all the words in the hash map. In this case, we have to store all the words in the hash map, right? So overall space complexity would be because of n into k here, right? So for this code, overall time complexity would be because of n into k log k, and the space complexity would be because of n into k, right? So I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.